Hello everyone, it's Julia. Welcome back to another video, and today I would like to talk about the unit circle. So I already drew a circle here, and before I teach you guys how you can memorize the radians in the unit circle, I would first like to explain what a radian is. So here we have a circle with radius 1. And if we were to go, if the length of from this dot to here was had the length of 1, then we would connect this dot and the center, and we would call this angle 1 radian. And now what 2 radians would be if we had this whole length, which would be 2, since it's 2 times more than this length, and that would give us this angle of 2 radians. And this angle would be 3 radians, since we have one more. And what you would call this whole angle would be pi radians. Now pi is 3.14, and it just goes on forever, right? And it's really close to 3, and that's why pi radians is here, and 3 radians is like really close to pi radians. Now I would like to draw another unit circle to explain to you guys how you can memorize the radians in a unit circle. So if I draw a circle here, then what I would like to do is put the pi here and then divide pi into 3 parts, and that would give us pi over 3 here and 2 pi over 3 here. So I would actually like to create 2 more lines that connect with pi over 3 and 2 pi over 3. So here it's pi over 3, 2 pi over 3, 3 pi over 3, which is just pi, and here 4 pi over 3. And since this is 4 pi over 3, it would give us 5 pi over 3 here. And here we would have 6 pi over 3, which is just 2 pi. Now if we were to divide pi into 2 parts, then we would have pi over 2 on the top here. And then if we were to divide pi over 2 into 3 parts, then we would have pi over 6 here. And so pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, and 4 pi over 6, which is 2 pi over 3. And if we draw just a few more lines, then we would have 5 pi over 6 for this one, and 6 pi over 6, and here 7 pi over 6, 8 pi over 6, 9 pi over 6, which is just 3 pi over 2, and then 10 pi over, and then 10 pi over 6 here, and 11 pi over 6 here. So now, if we were to divide pi over 2 again, but in 2 parts, then we would have pi over 4 in between pi over 3 and pi over 4. I mean, in pi over 6. So it would have 3 more lines created. So here it would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4, 6 pi over 4, which is just 3 pi over 2, 3 pi over 2. Oh, actually, wait, no, 3 pi over 2 here, and then we would have 7 pi over 4 here. Okay, now this was how you would memorize the radians in a unit circle. Now I would like to explain to you guys how you can how you can find the value of a trig function when it is at a specific radian. So I would like to start with explaining how to find the value of sine and cosine at a specific radian, and I would like to leave tangent at the end, for the end. So first, the horizontal line in the unit circle acts like the x-axis, and the vertical line acts like the y-axis. Now it's just like a normal graph, and so x comma y is equal to cosine theta comma sine theta. And so what I do not do is memorize all the values in the unit circle, because all you really have to memorize is the first quadrant. So if I draw the first quadrant here, we would have pi over 4 here, pi over 6 here, and pi over 3 here. So the way I like to memorize it is by creating horizontal dotted lines that connect to the vertical line. So what I write next to all of these is square root and leave that blank, and over 2. And I write that for every single. So I write that 2 times. Blank over 2, square root of something over 2. Now what's going to go into these square roots is the level it's on. So I like to think of this dotted line as the first level, this dotted line as the second level, and this dotted line as the third level. So the level gets higher. And so now, but you could also do this in vertical lines like this, and here it would be the same as this, except it's just across. So square root of 1 over 2, square root of 2 over 2, and square root of 3 over 2. Now, square root of 3 over 2 is equal to 0.866, and square root of 2 over 2 is equal to 0.707, and square root of 1 over 2 is just 1/2, which is just 0.5. And now this makes sense because the radius of this unit circle is 1, right? And so it's half of 1, and that's why it's just 1/2. And so we just found the value. So the y-axis is the sine theta, and so here at pi over 6, the sine theta here would be 1/2, like I wrote here. And for the cosine, we would have here square root of 3 over 2. And for the radian pi over 4, we would have square root of 2 over 2, and the same for sine. And for the radian pi over 3, we would have 1/2 for cosine, and square root of 3 over 2 for sine. And now for the radian pi over 2, we would have 0 for cosine, since there's obviously no value for the cosine here. But for sine theta, it would actually have the full radius, which is just 1, since it's the length of this line here, and the radius is 1. And to find the radian of pi over 3, we would have to do, okay, so now that we're in the second quadrant, everything would be the same that we found from the first quadrant, except all the values of cosines will be a negative, since the unit circle works like a graph, and we're now in the negative part of the x-axis, but we're still in the positive part in the y-axis. And so everything is the same except the front. It's a negative. So negative 1/2, comma, positive square root of 3 over 2. For square root of 3 over 4, we would have negative square root of 2 over 2, comma, positive square root of 2 divided by 2. And for this one here, we would have negative square root of 3 over 2 and positive 1/2. Now we're in the third quadrant here, and the way we would find the values of the third quadrant is just copy everything that we found from the second quadrant here, except even the values of the sine theta are negative, since we're now in the negative part of the y-axis. So like for the radian 7 pi over 6, we would now have negative square root of 3 over 2, which stays the same, and negative 1/2 instead of positive 1/2. And for 5 pi over 4, we would have negative square root of 2 over 2, comma, negative square root of 2 over 2 as well for the sine theta. And for the radian 4 pi over 3, we would have negative 1/2, comma, negative square root of 3 over 2. And I'll just write 3 pi over 2 alone. And so for the radian 3 pi over 2, we would have 0, since there's no value for cosine, and negative 1, since the radius is 1, but we're in the negative part of the y-axis. And now for the fourth quadrant, we can just either copy it from the third quadrant or the second quadrant or the first quadrant. And if we were to copy it from the third quadrant, then we would have to change the values of the cosine to all positives. But if we were to copy from the first quadrant, then we would just have to change the values of the sine theta to all negatives. And we'll still get the same value, so I'll do that. So for the radian 5 pi over 3, we would get positive 1/2 and negative square root of 3 over 2. And then for the radian 7 pi over 4, we would have positive square root of 2 over 2, the square root of 2 over 2, comma, negative square root of 2 over 2. And for the radian 11 pi over 6, we would have positive square root of 3 over 2 and negative 1/2. Okay, I'll erase this part so we have more room. And positive 1/2. So now that I have explained how you can find the values of sine and cosines, I would like to explain how you can do it for tangents. So now if I create another circle right next to our original one, then you should know that tangent theta equals sine theta over cosine theta. So for example, if we were to try to find tangent pi over 6, then we would have to do sine pi over 6, which is 1/2, 1/2 divided by cosine pi over 6, which is square root of 3 over 2. And then if we were to simplify that more, we would get 1/2 times 2 over square root of 3, which is just 1 over square root of 3. So we can just do it this way, but what I like to do it is just memorize it because I personally think that that's faster. So I would like to teach you guys how I like to memorize it for tangent. So the first thing that I do is draw a long vertical line next to the unit circle. And of course we have the lines. We're still going to need the lines. Okay. And so here we have the unit circle, which is very bad, but so what I do is just use the first quadrant and the fourth quadrant, and so I just connect the lines that we have already drawn to the vertical line that we drew. So now I just like to focus on the top part, and there are 3 things that you really just have to memorize, and that's the length of this here, the line is 1 over square root of 3. This length over here is 1, and that really does make sense since the radius of the circle is 1 and it's pretty much symmetrical. And the length of here is square root of 3. And everything is the same for the bottom part, except it's all negatives, obviously, since, yeah, it's a graph and we're now in the negative part of the y-axis. And so now, I would like to provide some examples so you guys can get the concept. So if we were to try to find the value of tangent pi over 4, then instead of doing sine pi over 4 divided by cosine pi over 4, we can just make a line, follow the line of pi over 4. This is the line of pi over 4, and then we immediately know that it's 1. So this is equal to 1. But if we were to try to find the value of tangent 2 pi over 3, then we could do, so this here is 2 pi over 3, obviously, and what we would do is just follow the line across, but this radian is 5 pi over 3, and so we would equal tangent 2 pi over 3 to tangent 5 pi over 3. And now here it's the longest value, so it's square root of 3 like the top, except we have the negative in front. So that's how we know what the tangent of 2 pi over 3 is. So negative square root of 3. And I would like to do one more example, which will be tangent 7 pi over 6. And tangent 7 pi over 6 is here, 7 pi over 6. And so if we just follow the line, we would get the angle of the radian pi over 6, and the value of tangent pi over 6 is equal to positive 1 over square root of 3. So positive 1 over square root of 3. And that's how you find the value of tangent 7 pi over 6. So that will be it for this video, and I hope you learned something, and thank you for watching, and goodbye.